you know what I'd like to do right now? I'd like to give you some examples of the types of problems we're going to be doing, and then after I explain how to do it, we're going to do a few of these, okay? Here's the type of polynomial I'm talking about, type of math expression that I want you to factor. They look like this. Stuff like that. I want you to notice something about this. Firstly, how many terms? 3 terms. Do these terms have the greatest common factor besides 1?
No.
Okay, so the GCF thing, it ain't going to work. How many terms are there again?
3.
Will factoring by grouping work?
No.
No, because factoring by grouping takes 4 terms. So we have to have a new method, and I'm going to teach you a new method on how to solve these. So here's one, and we're going to do all 4 of these examples at some point. So we can have minuses up there. We have different variables. It's all the same idea, as long as what you have here are 3 terms which share no greatest common factor. Now, the way I always teach this, I teach this according to what I call it the diamond method. It's kind of like an X, not really a diamond, but I think it'll help you out. Really, it's just a graphic organizer to help you organize your thoughts, is what it is. So, one thing I want you to notice, so how to factor. How to. One thing I want you to notice, if you have 3 terms, do you understand that all the time with these 3 terms, you could put them into this format, where you have something x squared plus something x plus c. And if you don't have any x cubes or higher, then everything else that had more terms could be combined by either numbers or x's or x squareds. Does that make sense to you? Okay, so here's what we're going to do. You know what, maybe I better practice just what they do. Let's look at the first example right up here. What is the b here? 4. No, it doesn't go with any variables, it's just the number. Just notice how it says bx. So what's the b?
4.
Good. What's the c?
3.
What's the a?
1.
Good, there's a 1 there. Remember how the coefficient, they're called coefficients, the numbers in front of your variables? The coefficients, if there's not 1, there's still 1. Because otherwise it'd be 0, and 0 times anything gives us 0. So we have to have at least a 1. How about here? What's our a, please?
1.
What is our b? Keep in mind with our coefficients, also our a, b's, and c's, it goes with a sign in front of it. So a is 1, b is what?
-8.
Good. What's the c?
15.
How about here? What's our a?
1.
What's our b?
-1.
-1. Very good. What's our c?
-42.
A,
1.
b,
4.
c.
-12.
Perfect. Are you guys okay with your ABCs? Next time, won't you sing with me? ABC. No, that's wrong. I'm not Michael Jackson, so I probably should do that. Here's how this works. We're going to create what's called the diamond method here. How we set this thing up, some teachers teach it differently. I like this way. What we're going to do, you know the letter B, right? That we found in all these. We're going to put B right up here. We're going to put A times C right down here. Now, the reason why I say A times C is because in about one more section, I'm going to show you when our A's are other. Did you notice this, by the way? Every A was 1 up here?
Yeah.
Very special case, okay? Sometimes we're going to have numbers up front, and this technique changes a little teeny bit after this step. But every single time you set this up, the B goes here, A times C goes down here. I don't want you to forget that that's A times C, because if the number's not 1, then that number is not just the last number. Some students get messed up on that. Now here's the whole deal. This is not something I can teach you. You need to be able to discover these numbers. You're going to find 2 numbers. These numbers must, at the same time, add to this one and multiply to this one. At the same time, add to the B and multiply to this product of A times C. If you find those 2 numbers, your factoring is done. Okay, that's basically it for these cases. So we're going to find 2 numbers. Let's just assume that that we've done that. This would be your number 1, and this would be your number 2. You with me? remember what factoring does? Does factoring destroy parentheses or create parentheses?
Three.
Okay. In fact, you're going to have, wait, how many numbers do you have?
2.
So you have 2 factors. You're going to need 2 sets of parentheses. And here's how the factoring works for factoring 3-term polynomials. Once you've found these two numbers, we put x plus number 1 and x plus number 2, and let's factor. Can I say something here real quick and have you all listen to me so that I make sure that you know that I said it? This right here, jumping straight from here to here, only works if your a is 1. If your a is not 1, you will have another step. This is a shortcut. It's a shortcut. Going from here to here is a shortcut. I can show you the long way if you want, but it's a short. Maybe I will show you the long way one time, but if your a is not 1, you can't do this. Nod your head if you heard me. You might not understand it yet, but just that you heard me there. If a is not 1, you cannot do this. If a is 1, easy, very easy. Let me show you a couple of them right now. And at least the last minute, I'm going to do one of them. That way you at least see it once. So let's do this one. Okay, so here's the thought process going through. I'm going to model it for you. I'm not going to model for you, but I'm going to model my thought process for you on how I would think about it. First thing, I check for a GCF. Do I have a GCF for those 3 terms?
No.
It's a 3-term polynomial. Can I do factoring by grouping? With every 3-term polynomial, if there's no GCF, I want you to immediately think diamond problem. Can you do that for me? So 3 terms, what's it called? Diamond problem. This is the diamond method or diamond problem, whatever. This is how you're going to factor it. So we look for our A. Everybody, what is our A?
1.
What is our B?
4.
C.
3.
Put the B here. Put A times C. I want you to always think A times C. What's our A again?
3.
3.
A is 1.
Times our C?
3.
1 times 3 is 3. Now, this is up to you. You have to think of 2 numbers which add to this guy and multiply to this guy. Add to 4 and at the same time multiply to 3. I'm going to give you some hints here, okay? The signs of these numbers will help you. If this number that you're multiplying to is positive, these have to be the same sign. Both positive or both negative. If that number's positive and that number's positive, these will both be positive numbers. If that number's positive and that number's negative, these will both be negative numbers. Otherwise, you'll have different signs, and you got to figure that one out, okay? So right here, I know that's positive, same signs. That's positive, they're both positive numbers. So I'm thinking about factors like 1 times 3. It's the only way that I'm going to multiply to 3 and add to 4. 1 times 3. Does not matter the order at all. Doesn't matter. Here's what I'm saying. As soon as you have these 2 numbers, and there's no A right here, we can go directly to our factors and be done. I'm going to show you one time and only one time why this works. Are you ready for it? Please watch carefully because it's going to blow your mind. I don't want you to cheat at it and not understand. I want you to cheat at it knowing that this is actually mathematically possible. Okay, so here's the idea. Do you really get that 1 plus 3 gives you 4?
Yes.
And you get that the 4 is the middle number? Okay, so here's what this allows you to do. Again, you will have a shortcut here. You don't have to do this every time. What you would do is you say, okay, here's x squared. I'm going to use those 2 numbers to separate this. Plus 1x plus 3x plus 3. Quick head nod if you can verify that that's exactly the same thing. If I combine my terms, I would get that, right? Now, here's what's kind of nice. How many terms do we start with?
3.
How many terms do we have now?
4.
What can we use with 4 terms?
Grouping.
Grouping. This is why it works so nice. If you group these 2, hey, we just did that. Factor the x out, x plus 1. Factor the 3 out. Oh, x plus 1. You see it? We just did it. X plus 1, x plus 3. We know factoring our group, I'm not going to re-explain it to you. Factor that out, we get an x, we get a plus 3, and those 2 numbers are exactly what those 2 numbers are, and they will be all the time. So, do you need to go through this every time?
No.
No. You can jump directly to here, okay? So this, for this type of problem, I don't care about. Here's what I do care about. Please listen carefully here. If this number's not 1, as soon as I put a 2 there, you have to do it this way. Did you see the difference? This right here, jumping directly from here to here, is a shortcut. And it works every time as long as your A is what?
1.
Okay, that's what I want you to know. Did today make sense for you?
Yes.
We're going to jump right back on this tomorrow. All right, so let's continue. We're going to keep up with this factoring of trinomials, and probably for the rest of the day, I'm going to sound like a broken record because I want to beat this into your heads so that you think the way that I think about these, okay? That way you get them right all the time. So when we're factoring, whenever we're factoring basically anything, the first question that we have with polynomials, where you have all the same variable, is firstly, is it in order? I'm always going to ask you that. So is this in order, how we like to see our polynomials? Basically descending exponents where the constant is at the very end. Is that in order for us?
Yes.
Do you guys know what I'm saying about in order? There's an x squared, there's an x, and then there's a constant at the very end. That's what we like to see. Also, is the first term positive? We like to see that too. So if we're going to factor, we want to make sure our first term becomes positive somehow through factoring. Next thing we check for, do we have a GCF? A greatest common factor that we can pull out of these 3 terms?
No.
Okay, after you check those things, is it in order? Is the first term positive? Do we have a GCF? After you check those, then we start looking at the number of terms that we have. If we have 4 terms, we already determined that the 4 terms we use, oh, everybody should know it, the 4 terms we use, that was like 2 people, oh my gosh. If you have 4 terms, how do you factor in this class? That was better, that was more than 2 people. If you have 3 terms, the only thing that we can do in this class, the diamond method. I call it the diamond method. It's just factoring trinomials. I call it diamond method because it's just a nice way to remember it. So the way we go through these, how I showed you, you're all familiar with your ABCs, right?
Yes.
What's the A here?
1.
What's the B?
-8.
What's the C?
15.
Anytime you have a 3-term polynomial and you factored out the GCF, you're going to go to a diamond problem. You're going to make sure, of course, it's in order and no GCF and the first term is positive. After you do that, the B coefficient goes here, the A times the C goes here, and then you find 2 numbers. The numbers must add to the B and multiply to the A times C. So this is really up to you to be able to find these. Now I can give you some hints, like I told you I would, so I'll do that for the first 4 examples, and then really it's up to you. I'll give you every case of these different things that you have, but then it's kind of on you to find them. So here, that number's positive. You're multiplying to that number, meaning that both of these signs will be the same. Positive times a positive is positive. Negative times negative is a positive. These are going to be the same sign. Also, you're adding to a negative. If these are the same sign, and they add to a negative, they both have to be negative. So right now I know that that's a negative, that's a negative. Now, that makes it easier. That way we're kind of limiting what we have to do as far as, well, we don't have different signs here. So we're thinking about some numbers that multiply to 15, add to 8. They're probably in your head right now. What are they?
5.
Yeah, and since we know they're both negative by this process of elimination, we got -5 and -3. Quick head nod if you're okay with that so far. Now, here's the most important thing that I want you to get. The A determines what you do next. If your A is 1, like this whole section is, okay, your A is always going to be 1 in this section. But I'm trying to prepare you not just section by section, but factoring. If your A is 1, you get to do a shortcut. You are done practically with this problem. Almost done. I mean, the rest of it's really easy. If the A is 1, you're practically done. It even rhymes. Nice, right? The A is 1, you're practically done. If the A is not 1, you're going to have more work to do. And I think I alluded to that last time when I did the extra work for you. Remember that? Last minute of class I did that. I proved it basically. Well, the shortcut works if A is 1. We just go, well, factoring creates parentheses. I've got 2 numbers here. So I keep the variable that's up here, x and x. That's through FOIL how we get our x squared. I put the 2 numbers that I just found. Negatives become minuses, and that right there is factored. That's the factorization for a 3-term polynomial. You will typically, if you're doing diamond method, you'll always get these 2, these 2 sets of parentheses. So if you guys feel okay with that so far, can you check your work?
Yeah.
Yeah, just distribute it, FOIL it. It's going to be exactly the same. Let me go real quick, try 2 more examples with you, just so we're really thorough, and then I'm going to give you something to do on your own. So next one. We're going to move a little bit quicker, but I'm still going to ask the same exact question. So first question is this. Is this in order for us?
Yes.
Is the first term positive? That's what we like to see. Is there a GCF, a greatest common factor, for these terms? How many terms do we have?
3.
Those are the questions I want you to ask every time, okay? Because that's going to lead you through what to do. Now, if there's 3 terms, can I use factoring by grouping?
No.
Doesn't make sense. That's for how many terms?
4.
That's right. So 3 terms, we have a diamond problem, or a diamond method. So we're going to make our diamond. Can you guys tell me, what's your A?
One
What-
word.
The A is always just numbers. Always numbers. So it's the number, it's always a coefficient.
1.
Good. So what's our B?
-1.
Negative 1. Very good. What's our C?
-42.
What goes here?
-1.
Good. Our B, -1 goes here. A times C, yeah, I know A is always going to be 1 for us right now, but I want you to get in the habit of doing A times C. Think about it, A times C, because a lot of people, when I start doing things like this, they'll still put -42, and they'll get the problem wrong. Because we always want to make sure that we're multiplying this number times this number and put it in here. So in our case, we got -42. I want you to think, don't say it out loud, think about right now as I'm thinking about these. What 2 numbers you can work with. Don't say it out loud. I want everyone to be able to do this. Okay, this is something I can't really teach you. You just got to go through and be able to find 2 numbers which add to -1 and at the same time multiply -42. There are hints. If that number's a negative, these signs are different. One's a positive, one's a negative. So now one of those is negative. If that's a negative, it means that the bigger of those 2 factors that make 42 is the negative number. So for us, I'm thinking 6 and 7. Did you find 6 and 7? So 6 and 7 is going to work, but you got to pick the right one to be negative. Since this is a negative number and we're adding to this, the bigger out of those is going to be the negative, the smaller of those is going to be the positive. Absolute value-wise is what we're talking. And double check it. Please don't get any further until you double check it. Is -7 plus 6 equal to -1? Good deal. Is -7 times 6 equal to -42?
Yep.
Doesn't make sense to get this and have it wrong and then continue, right? We want to make sure that we're right. Now, I told you something just a minute ago. Is this one of the ones that I can do a shortcut on and go directly to my factors? Or do I have to go through more work? What do you think? Shortcut. Okay, why?
Because your A number.
That's it. That's all you need to know. A is 1. A is 1, then you're done. I like that. You can use it if you want to. Trademarked.
I understand that, but I got stuck on why in the diamond method, why it was a -1 right there. Where'd you get the -1?
What's the number here?
Oh, gotcha.
It can't be 0.
Yeah.
Okay, so factoring a 3-term polynomial is going to give us 2 factors. Now here's the deal. What variable do we have here?
Y.
So don't put x's. Here's was x's, yeah, put x's. Don't automatically just change your variable to x all the time. It's really common because people are so used to x. But if we have y's, yeah, you got to put y. So we're going to have y. What's the next thing we're going to put here?
-7.
-7. So a -7 means -7. Do we just put a 6 like that? Does that make sense?
That's +6.
Positive 6 changes to a +6. That's the idea. Now, does it matter the order in which you have these?
No.
Multiplication is commutative. So if you had put your +6 and -7, not a problem. It's still the same factorization. Am I making sense to you guys so far? Okay, I think we have one more, and then I'm going to give you probably 4 to do on your own, 4 or 5. I want to make sure you guys can do this. Okay, you probably know the questions I'm going to ask you, but I told you, I warned you ahead of time, I'm going to be a broken record here. Because when I give you examples on your own or on your test, I want you to think like this. I want you to think through, okay, first thing, is this polynomial in order? Is it in order for us? It's important to have this in order. Second thing, is the first term positive? That's good. We need that for our factorization. If it's not positive, we run into some problems here, all right? Next thing, is there a GCF in our terms?
No.
That goes into all of our terms. Okay, so we think order, first term positive, GCF. That's what we think. Next, we count the number of terms. How many terms do we got?
3.
Not 4. So grouping's off the table. We're going into, oh, what do we use for 3 terms? Perfect, so we're going to do it. Okay, everybody, what goes here?
4.
What goes here?
-12.
Good. We multiply 1 times -12, we get -12. And then you're going to think of some numbers. Now, that sign's negative. It means one of these is negative, one of these is positive, because we're multiplying to a negative number. Doesn't matter where you put that negative, as long as you just have one negative and one positive. That number's positive. It means we're adding and getting a positive number. It means out of these two numbers, the bigger one, absolute value-wise, is the positive one. So we're thinking, oh my gosh, will 3 and 4 work?
No.
But 3 and 4 gives you 12. It won't get to be that one. So I've got to have 2 and 6 somehow, but I'm going to say, well, since the number we're adding to is positive, I can't do negative 6. Because if I did negative 6 and 2, that would give me...
Negative 4.
So use this kind of process of elimination almost, or at least some critical thinking, to realize the smaller number's negative, the bigger number's positive, and then we double check it. Negative 2 plus 6, oh yeah, it's 4. Negative 2 times 6, practically done. Do we have to go further, or can we do a shortcut here? Why can we do the shortcut?
Because A is 1.
So then we're going to do, wait, did you say Z is 1 or A is 1?
A is different.
Okay, A is 1. Z, I don't know what Z is. There's no way to solve this, okay? It's an expression, not an equation. So we can't solve it, but the A, the number in front of Z, is 1. That's how we know we can go to the shortcut. I kind of proved it last time. What do I put here and here?
Z.
Yeah. You sound like my little math robots. That's awesome. What do I put here? Z. Please feed me more numbers. Yeah. Okay, next we go, well, negative 2, minus 2, positive 6, plus 6. Check it by FOIL, your distribution, and you're done. I know it's going to work. I've checked it before, but you should check this, especially when you have like a hefty-duty problem and you're halfway in the middle of it and it asks you to factor. You don't want to mess this up, all right? Because this will make or break your problem. So as long as we can double check it, make sure we're right, then we continue. Show of hands if you feel like this is doable for you. Okay, I want you to prove it to me. I'm going to give you some examples. I'll be walking around if you need. This is going to take some time, so take your time on it. It's okay. I'll give you maybe like 5-6 minutes to do these. It should be about maybe a minute or two a problem when you're doing it. Once you get it down, of course, it takes practice to do that. So let's start here. Okay, like I said, I'm going to be walking around. If you're struggling with this idea, not necessarily just one problem, that can happen. If you can't find the appropriate numbers, that can happen. You struggle with one problem. I mean the idea. If you're struggling with the idea, let me know right now and I'll try to give you a hand. Also, if you finish these quickly, what should you be doing in the downtime between when I'm up there and around here? What should you be doing? Check it. Make sure that you're right. Get into the habit of that. You guys start to see what I'm talking about it's kind of up to you to find the numbers. The setup's great, but honestly it's just a graphic organizer. It's really you thinking of these two numbers that makes this possible. That's the big deal here. And unfortunately I can give you some hints, like the whole, well, one's negative, one's positive deal, but it really takes some trial and error sometimes to get these. So it might take you some thought. I can't just snap my fingers and make you make you really good at it. It just takes practice and thought. Have you all done at least the first two of them? Okay. I'll give you about another minute and a half or so. Try to wrap up as many as you can, then I'm going to get started on the board. Question? Do what you can. One's going to be negative and one's going to be positive, right? Okay. So remember that you're going to be subtracting there to get 5. So that means that one's bigger and one's smaller. I have 36 right now, but I have 35 here. Oh. All right, tell you what, I'm going to give you, I'm going to get started up here. Either you're stuck or you probably finished at least 3 or 4 of them. So we'll start on this one that I gave you first. I hope that you were thinking through this the way I thought through it when I was modeling this for you. So the first thing, is it in order? Yeah, I'm going to check that they're all in order. It looks like they're all in order. We want the square, then the variable, then just the constant by itself. I'm going to check to make sure that my first number, my first term is always positive. Positive, positive. So it's all set up for us. I'm going to check to see if there's a GCF. I'm going to do this all at once, that way I don't have to slow down while I'm going through each one, okay? No GCF. That one doesn't have a GCF, this one doesn't have a GCF, none of them have a GCF. But we always check it first, don't neglect that. Remember when I told you about GCF? No matter what I tell you in the future, always check for GCF. You remember that? Always, without saying anymore, you always check for GCF no matter what when you're factoring. After that, we count the number of terms. If they had 4 terms, yeah, we'd be grouping. Here we have 3 terms in each case, which means we're going to be doing a diamond problem every time. And you'll get the hang of it really quick on what goes where. The hard part about this is when you figure out that this is 9, 1 times 20 gives me 20. The hard part isn't doing this. Okay, this is the easy part. I didn't give you the hard part. I didn't really teach you how to do that every single time for every problem because I can't. All these numbers are going to be different every time, all right? It's up to you to figure out, well, 9 goes there, 1 times 20, 20 goes here. Now I got to add to that number and multiply this number. I know because I've been doing this a while, right? I'm pretty good at it. You guys need some practice at this for some of you. Some of you guys are really good at it. This is going to be 5 and 4. They're both positive. They add to 9, they multiply to 20. Did you guys get that one? Okay. After you do that, don't just stop at a diagonal problem. This is just an organizer for you. It doesn't solve it. Well, I can't say solve it. It does not factor it for you. What factoring means is you take these numbers and you use it. You say, well, factoring means create parentheses. Factoring means that I'm going to take these two numbers, and if they're positive, I put plus. If they're negative, I put minus. And because I have a 1 here, it means I can go to the shortcut. I can do just my 2 factors, and I know it's going to be right. Show of hands if you got at least that one. If you got that one, that means that you understand the idea of factoring. If you didn't get the rest of them, that means that you're struggling with finding the numbers that work there. That's okay. You can work on that as long as you get the idea of factoring. What I really want right now is that you understand the concept of in order. Do you? The concept that the first term, really, it should be positive if we want to factor using these methods, because it's really hard if it's not. You get that? You get that the first thing you should be doing all the time when factoring is looking for GCF. Yes, no? Do you get that with 3 terms, diamond problem is the way to go? Okay, and lastly, if we have an a that's equal to 1, after we do this, we can go directly to the factors. And if we don't have an a that's 1, we have more work that we need to do. Show of hands if you understand all those concepts. Then you get the factoring. Now, sometimes it might be a little difficult to find the numbers, but that's the idea. So I think you've mastered the idea, now it's just kind of working with it. What number goes here?
5.
How about on the bottom, what goes there?
Negative 36.
That means different signs. That's a negative, different signs. Bigger one's positive, so I'm looking at 9 and 4. Is it negative 9 or positive 9?
Positive.
And negative 4. That adds to 5. That multiplies to negative 36. So since we have 1 here, we go, all right, that's awesome. I can do x minus 4. I can do x plus 9. I use those two numbers, that negative 4 minus 4. Positive 9 plus 9. And I know that I can check that with FOIL, and it's going to be absolutely right. You guys 2 for 2? Good. All right, next one. Still the same thing. We've checked the conditions for our diamond problem already. What number is going to go up top?
Negative 13.
On the bottom, please.
22.
Now, that's a positive, yeah? And that's a negative. It means they both have the same sign, and that's a negative. They're both negatives. They have to both be negatives. Now, the numbers that multiply to 22, there's not many of them. There's 1 and 22, and there's 2 and 11. So it's got to be 2 and 11. So 2 and 11, well, that's pretty easy since they're both the same sign. Does that add to negative 13?
Yep.
Good to go. There's a 1 here, means I go directly to my factors. And now we factored it. Factoring always creates parentheses. You have those two numbers, you're going to create 2 parentheses. So far, so good? Okay, next up. Conditions are met for our diamond problem. We're all good, no GCF, all that fun stuff. Negative 3, negative 40. We go, okay, well, if that's a negative, these things have to have different signs, don't they?
A negative and positive.
Yeah, it's got to be. Negative and a positive. Now, that number's a negative, meaning whatever we find here, whatever factors work, the bigger one, absolute value-wise, is going to be negative, and the smaller one's going to be positive. I'm looking at, what?
8 and 5.
8 and 5 somehow. Now, because that's negative, it's going to be negative 8 and positive 5. Let's double check, though. Let's see, adding them, negative 3. Yeah, that works. Multiplying them, negative 40. That works, too. Now, just put them in your factorizations. Why don't we have to do the extra work on this? Why can we go directly to my factors? Why can we do the shortcut? Explain that one more time.
8 and 1.
Very good. By the way, what variable should I use here? Got to make sure you do that. Can you double check your work? You should. Show of hands if you feel okay with these ones so far. Okay, last one. GCF?
No.
In order? Yeah. Well, 3 terms means diamond problem. Number here is?
6.
Number here is? Give me 2 numbers that add to 6 and multiply to 15. I dare you. I dare you to. Can you find? Did you try it at least? Okay, how long did you spend trying it? A long time, right?
I gave up.
Okay, this proves to you something that I wanted you to try. I'm not going to just give you stuff for free a lot of the time. I have you work for it. Do you believe me when I say there's no 2 numbers that work here? Okay, then you should also believe me when I say that not every 3-term polynomial is factorable. You're going to run across some that this does not work, and this does not work, and this doesn't work, and this doesn't work. This is one of those times. You go, I don't know. And then you go, then you go, what am I supposed to do with this? And you go, well, nothing. You can't factor this. There's no 2 numbers that allow you to factor it. And so what you call it, you don't do any other work. You don't make something up. It's not factorable. We call that situation prime. It's a prime trinomial. It just means you can't factor it. You need to understand that there's some trinomials, some polynomials that you cannot factor. Show of hands if you understand that. Hopefully that proved it to you after you struggled with finding those numbers. And man, am I a little slow today? Or did Leonard make me? Darn you, Leonard! You got me. Well, sometimes you can't do it. Can I move on a little bit? Do you understand the idea of factoring when your A is 1? I'm going to move on a little bit and give you some special cases of things that you can do. They look a little weird, But stick with me here, it's the same basic idea. So, some special case polynomials that I want you to see. So first one. Okay, that looks a little funky because it's like nothing that we've really seen before, besides some of those 4 terms. But when we look at it closely, how many terms do we have? 3 terms. That means grouping is not going to work, all right? Also, is it in order? Well, yeah, kind of. I mean, we have x squared, then we have x squared, then we have y squared. That's kind of nice. But the order sort of thing doesn't really flow because we have 2 different variables, all right? So, all right, that looks fine. Let me tell you something. If you have 3 terms, on certain special cases, you can still make them a diamond problem. Sometimes you can't. This is one of the special cases where you can. I'm going to show you that one time. So if we did the diamond problem here, because we have 3 terms, also, check this out, do we have a GCF? I don't want to forget that ever. Do I have a GCF?
No.
Besides a 1. So what number would go up here if you had to put one? Good. And here? Same signs, both of them negative. This one should be kind of easy.
Negative 10 and 10.
Yeah. If you do negative 10, do you understand why they have to be both negatives in this case? Got to add to a negative, got to multiply to a positive. It's the only way it's going to work. This adds to negative 13. Yeah. This multiplies to positive 30. So check it out. If you didn't have, listen, if you didn't have the y's, if these weren't here, what you would have, you see what I'm talking about? If you didn't have the y's, you'd factor this, and it would be xx, and you do minus 10, and you do minus 3. Would you agree with that? To get the y's, just put a y. And that's going to work. If you notice that, this will give you the x squared, won't it? And this will give you the negative 3xy. This will give you negative 10xy. 13xy. This will give you positive 30y squared. One more thing before I answer your question. If you do this by that, remember the method I showed you like the last minute class last time? It's earlier on the video if you're watching. You can still do it by separating this. If you did minus 10xy, minus 3xy. Do you remember me showing that to you? If you don't, maybe go back and refresh your memory on the video. This has how many terms?
4.
And do you remember, thanks one of you, do you remember that these terms add to that number? That means that I can split this up into 2 extra terms. I could do my minus 10xy, minus 3xy. Does this still make minus 13xy? Okay. And then my plus 30y squared. Grouping still works. This is a longer way. Remember I told you if that's a 1, you can shortcut it. Are you with me? If it's a 1, you can shortcut it. If it's not a 1, you have to do this, but I'm just kind of proving to you that this will still work either way. So if you factor out the x, we get x minus 10y. Oh, look at that. If we factor out the 3, do you remember what this does? Come on, tell me. If I have a minus there, what's that force me to factor out?
A negative.
So if I factor out my negative 3, I get, I missed something. What else?
Y.
That's right. So here I have a y, I have a y squared. So I'm factoring out my negative 3, it's forcing me to factor a negative. This says 3, this says y. So if I factor out negative 3y, I get x. What's that sign going to change to if I factor out a negative?
Negative.
And I'm going to get 10y. Do you see that it's going to work now? I've covered this enough times for you, hopefully, that you see this is going to be obvious. There's 2 big terms. These are the same factor. If I continue to factor, I get x minus 10y. We get x minus 3y. And I'm really hoping that's exactly what I showed you the first time. Did I show you that? Okay, so it still works. If that's a 1, you can still do the shortcut. Just don't neglect the y's. Just a little addition there. Show of hands if I explained that well enough for you. These don't happen all the time, but if I don't show it to you, people are going to go, oh my gosh, because it looks a little weird, doesn't it? What in the world's going on? Same idea. Same idea. Okay, let's keep on moving here. This is a good one. And you look at it and you go, wait a minute, that's weird. What's weird about this?
X to the 4.
We've never seen those before, right? And besides maybe factoring out the GCF. But does this have a GCF?
No.
Hello, have a GCF?
No.
Is it in order?
Yes.
Yes.
In order, 4, 2, constant, got it. No GCF. Is the first term positive?
Yes.
We like that. How many terms do we have?
3.
What do we do with 3 terms? Let's try the diamond. So if we try the diamond, we're going to have 10, we're going to have 21. Can you verify that for me, 10 and 21? Okay. Can you think of 2 numbers that add a 10? This one, oh, come on, this is an easy one. This is a good one. I love these ones. They're all positive. What is it?
3 and 7.
Yeah, 3 and 7. Now, you can do this a couple ways. You can do the shortcut on this, as long as you understand what the variable is. I believe you can still even group it. I'll show you that if you really want. So here's x to the 4th. Do you remember that these split that term up?
Yeah.
If you get this, the next section is going to be so freaking easy for you. You're like, oh, I love that stuff, okay? So if you understand what I'm about to do, that these numbers had to add to that one, therefore these numbers are how I split this term up. Plus 3x squared plus 7x squared. Are you with me still? And then plus 21, tack that onto the back end. Look it. The only reason why we're doing this, right now, is to change 3 terms into 4 terms. Why do I want to change 3 terms into 4 terms? Why? And grouping's easy. That's why. So once I do this, I can group. And here, I'm just going to do it for you because we've covered it so many times, okay? Here, the greatest common factor is x squared. I do it. I get x squared plus 3. Plus, here's the other one. I factor out a 7. I get x squared plus 3. Is that going to help us? Yes, no, what do you think?
Yes.
Yeah, because here's 2 big terms now, and we have the same factor. If I factor out the x squared plus 3, as we've done many times before, I remove this by factoring by division. Remember, factoring always creates another set of parentheses. I remove this, I get x squared. I remove this by factoring by division, I get plus 7, and that's completely factored for you. Isn't that kind of nice? Kind of weird, right? Check it out. Could you have gone directly from here to here?
Yeah.
3, 3, 7, 7. The only thing you got to realize is that's not x squared anymore, it's x to the 4th. What do you need to get x to the 4th? You need an x squared times an x squared. And that's how you'd figure that one out. Show of hands if that one made sense to you. Cool, okay. I know I'm not giving you a whole lot of opportunities to do this on your own. Frankly, we don't have a whole lot of time for that. I'm just kind of saying, if you get this, these are the same ideas. I'm just giving you special cases. That way when you see them on your test or in your homework, you don't get super intimidated, okay? You go, okay, I can do this. It's the same idea. If you don't understand how to get directly from here to your factors, please, please trust me that you can always split these up and use grouping. You can do that every time. So if you're like, man, how in the world do you get, just use grouping. How in the world do you get from here to here? Just use grouping and it'll show up for you. So if you ever get stuck, what are you going to do? Grouping. Just make 4 terms and group it. And that's why you use these 2 numbers. Understood? These ones, these are pretty easy. It's just a shortcut. So the real work, the real stuff that we do all the time, this is just a shortcut. It's really this. It's separated into 4 terms, it's grouping them, and it's finishing off the factoring by grouping. It's separated into 4 terms, it's grouping them, and it's finishing off your factoring by grouping. You with me? Okay, let me show you, tell you what, we'll do 2 more, and then we'll put all of this stuff together and deal with the case where A is not 1. Is this stuff getting easier for you than when we started? I hope so. I hope it's not getting harder. Oh, I mean, I hope that you're learning something here. Tell me something about this problem. It's one of the first things we check.
GCF.
Okay, we check GCF, but first we probably want to check this.
Order.
The order. Is this in order?
No.
Put it in order, because if you start trying to do a diamond problem right now, it gets a little funky. especially if you're a person that would put A as 30, don't do that. Put this in order first and then start checking the stuff. So as soon as we arrange it, that really helps us. What's supposed to go first?
Z squared.
And then what?
Minus 31Z.
Remember that terms
Plus 30.
always go with the sign in front of them. So we have the z squared, cool. We get the minus 31z. When you have a positive 30, I know there's not a sign in front of that, but don't just put 30. I have z squared minus 31z 30. That looks really weird, okay? You need still a 3-term polynomial, so you're going to put the plus in there signifying that you're adding the 30 or that it's positive 30. Does that make sense to you? Now what are we going to do? What should you check for before a diamond problem? Does this have one?
No.
But we check. And now we go, okay, 3 terms, diamond, great. So once we set up our diamond problem, now it's kind of a non-issue. I just want to make sure that you understand if it's out of order, put it in order, it makes your life easier. Negative 31, we got 30, wait a minute, negative 31.
That doesn't work.
That's
Negative. We'll tell you what, let's use our method here. They're both negative, do you see why? They're both negative. Yeah, you gotta make it positive by multiplying and negative by adding. They both have to be negative. Only way this works if you have 30 and 1. So it's negative 30 and negative 1. Does that add to negative 31?
Yep.
Does it multiply to positive 30? Yeah, so sometimes you might have to think on it. Don't give up on it like this one, okay? This was a 1. But some of them, I mean, don't give up right away, and you still gotta think about it. Now here's a good question. Do I have to go through all this process and do the grouping?
No.
If I get stuck, can I go through this process and do the grouping?
Yes.
Yes. But with z, the coefficient of z squared being 1, I can do z minus 30, I can do z minus 1, and sure enough, we are done. Could you check your work?
Yes.
Should you check your work?
Yes.
Am I going to? No, because I'm lazy. But you should, because it's your test. I've already passed this class like a long time ago. At least last year. I mean. All right, one more. Oops, messed up. Actually, do you want to try one? You guys try one on your own, see if you can handle it? I think you can. It's a little challenging, not too bad, it's a little challenging. You just got to follow the steps that I've talked about. You got to follow the steps I've talked about. Go for it. See if you can do it. What's the first thing that you checked for when dealing with this polynomial? What did you check for?
Order.
But even before the GCF, actually.
Order.
Order. Is it in order?
Yeah.
That's great. Is the first term positive?
Yeah.
The reason why we ask that, because if it's not positive, even if you did not have a GCF, which you do here, you'd factor out a negative. Okay, that's how the diamond problem works. So the -1 would have been your GCF. Does that make sense to you? So for instance, if I did like this, first thing I'm doing here is factoring out the negative. It's just changing all my signs, and then I start going through that. So here, order, yeah, very good. First term positive, cool. That's going to help me with my GCF. Now I check for a GCF. What is our GCF here?
5x to the third.
Yeah, you're gonna pick as much as possible. So 5 for sure, and then as far as the variables, remember going to lunch, you gotta go to a restaurant everyone can afford. So the x to the third is the biggest power that's shared by all of them. So we're gonna factor out the 5 and the x to the third. And if we do, I'm gonna do it kind of quickly, we're gonna create brackets here. We're gonna have x squared, 5 divided by 5 is 1, x to the 5th divided by x to the third is x squared, minus, because we're not changing signs, we didn't factor a negative. 25 divided by 5 is 5. X to the fourth of x to the third is x. Another minus, 30 divided by 5 is
6.
x to the third divided by x to the third is 6 times 1 is 6, which is how we get down that far. Now, a lot of rookies will stop right there because they go, oh, I factored. You did. Is factoring a one and done type of idea? You can factor many, many times, sometimes like 3, 4 times in a problem, potentially. It's ugly, all right, but you can do it. So here, we don't stop, we check this now. Now we have a technique for solving these. How many terms do we have?
3.
You don't have to check the order because it's already in order. You don't have to check a GCF because you already factored the GCF. Now you just do a diamond problem. So if we do a diamond problem, typically, if you factor GCF, these are pretty easy. Okay, they'll get really nice. If you fail to factor the GCF, these diamond problems can be really tricky. Because if you don't factor the 5 out, even if you do the x's, 25 on the top and 150 on the bottom, that's pretty big, right? It's going to take you a lot of thought. And then once you do that, you'll still have a GCF within those factors, which is going to be stinky. So do your GCF first, it'll save you a lot of time later. Anyway, we're going to put our -5, we'll put our -6, and we go, all right, well, they have to have different signs. The bigger one's going to be negative. What is it? That's right, -6 and 1. Please don't get confused on 3's and 2's all the time. Sometimes they're 3's and 2's, but you've got to make them work, okay? So this, does that add to -5?
Yep.
Does it multiply to -6? Okay, so we're going to have, if we just ignore this for a second, if we had just this, it would be x minus 6. Explain to me why I'm going directly here and I'm not doing this stuff, please.
So A is 1.
It's perfect, yeah. So we have x minus 6, we have x plus 1. Now, we're going to wrap this up with a bracket. We're going to not forget about this guy. 5x to the third, and that's completely factored. I'm going to show of hands if that one made sense to you, feel okay with it. Question?
When you're on Math Excel and you're turning your problems, do you have to have the brackets?
You know, I don't think so. I don't think that you do, because that it's kind of redundant in this case. The reason why we have the brackets here, you do have to have them here, okay? Down here, because you're multiplying, and multiplication is commutative and associative, you really don't need them. So you don't have to multiply these first and then do that. You can have it just like that and be
It
appropriate.
takes the double brackets on that.
I'm sure it will. It'll do
I've been
either
using the
one.
double brackets, I didn't know you can use them.
Yeah, you can. That's a perfectly appropriate answer as well.
Okay, so if I was to put this as the answer on a test, it would still be correct?
Oh yeah, yeah. That's usually the way that I would put them. The brackets just kind of hold it. But as soon as you have it factored, you don't need those big brackets. Good question. Any other questions? Okay. Because this flows so nicely, we're going to start the next section. We're actually going to skip 6.3 because it's a way of teaching factoring I really don't agree that much with. I like this next method a lot better. So we're going to skip to 6.4, and we're going to put this idea right here to the test when A is not 1. So here's going to be my point. If you understand this concept of splitting up your middle term, this next section is going to be really easy. Do you understand this concept? Yeah, I taught it a certain way, that way this would all make sense to you, okay? I had a method to my madness. So